My name is Seeta Somagani. I'm working at Volt Active Data.
How long the company has been?
13 years.
So go through different cycle and the buzzwords, right?
As Volt, I believe it's a transactional streaming database is a term that applies to us. And
Hi everyone, this is Joe. Welcome to the new episode of Streaming Caffeine. Actually, this is the first episode in this new year. I'm got quite busy on the project, I mean other things, but I do want to keep this more like a casual way to talk to person in this data streaming space or some best practice, some interesting use cases. And today I'm so glad to invite Seeta in this conversation, and we know each other a little bit in different Slack communities, but I guess maybe it will be better if you can just introduce yourself and also your project or company.
Yep. Hi, Jove. Hello, everyone. Thanks for inviting me to talk. So my name is Seeta Somagani. I'm working at Volt Active Data as a solutions architect. So I work with customers and prospects in basically understanding their needs and see where Volt can be a right fit. My background has mostly been in product development. I've always been working for companies based out of Boston. I'm originally from India. I moved to the US for my master's and then started working for companies in Boston. A couple of different product companies working on the development of the product, and then moved into professional services, which was a little bit of a different game, trying to get more closer to the customer, interpreting their problem before you're actually writing code to solve the problem. And then I figured, go even bit ahead and before professional services get into pre-sales, so we can even identify the product market fit and understand the customer's problem even earlier. So that kind of was something that I found interest in, and joined the pre-sales here at Volt about 8 years ago. It feels like yesterday.
Wow.
8 years flew by already. The opportunity here was for me to move into the data space. Back then, database meant Oracle, SQL Server, Postgres, or a NoSQL database, Mongo or something. So when I first heard about Volt, I thought, here's another NoSQL database. Of course, it has to be NoSQL because it's a new company, and that's the the way the new databases are being built. So it took me like a lot of learning to really understand what is the new SQL database the original categorization that sort of worked initially. So to cut my introduction short, I've been here 8 years, work with customers and love to advocate for the product and speak with the community. So that's what I'm hoping to do today. And thanks for the opportunity again, Joe.
Yeah, likewise. And so Volt, if you get maybe 1 or 2 minutes, nothing 1 or 2 seconds, but 1 or 2 minutes, how to describe Volt?
Yeah. I guess there's a couple of different ways of explaining what our product does. Let me take the historical perspective first, right? So created by Dr. Stonebreaker, Turing Award winner. He created many database products: Postgres, Ingress, Streambase, Vertica, Tamer, and Volt was spun out of Vertica actually. So if Vertica was based on the C-Store paper that Stonebreaker wrote, Volt is based on the H-Store paper that he co-authored. The concept is essentially, it's a horizontally scalable, transactional, in-memory database. So that was the original intent. The intent was the traditional databases take too long. There's just overhead, like 80-90% of the time, you're using up the cycles for buffer management, for locking, latching, the overhead. So Volt was built to be efficient at transaction processing. So eliminating disk, right? In-memory database was not a mainstream concept then. It was just starting to take off. And NoSQL databases were at the forefront of that. But keeping the relational guarantees, keeping the guarantees you expect from a traditional database, keeping the relational semantics, how can you build a product that can scale? So a lot of our customers initially, they replaced their traditional databases with Volt, MySQLs and Postgres and Oracle, and because they needed the scalability. But you see, their use cases were also being different, right? Originally it was, hey, my queries are too slow. I have a lot of data, my queries are slow. How can I scale? Maybe if your data set fits into the memory, use an in-memory database, so your queries will be faster. But then slowly the pattern started to emerge that at least from the field, it started to emerge that, hey, it's not just a faster database. It's a database that's better suited for a different data pattern. Because it's in memory, you're looking at a window. It's you cannot have all of the data, so you essentially you treat the data as unbounded. You're just looking at a window of the data, so essentially you are looking at a stream of data. Right, moving away from the transactions or querying or running CRUD and stored procedures, the old world, moving into the newer pattern where you're processing the data as it's coming in, you're maintaining the state that's needed to process the data, and also pushing the results or whatever calculations or records you would like to export. So the use case based upon the experience in the field was more for streaming, processing streams of data with the transactional guarantees. And then we continued evolving from there. And we actually, with the evolution and the industry acceptance of stream persistence like Kafka, we added features to support that. Now, our worldview has been shifting from like a data centric and a system centric view, or a stream centric view, where these our core capabilities work for streaming. How can we mold it and uh, tell a good story around how you can use Volt on streaming your streaming data, especially when you need transactions, especially when you need high levels of consistency.
So Volt, how long the company has been?
13 years.
So go through different cycle and the buzzwords, right? And I guess for a while people talking about, SQL is everything, and then people say, oh, come on, we don't really need the SQL, no SQL, and the new SQL mentioned. I guess nowadays people, and that's my impression, that is people don't talk too much about NoSQL, right? So I'm even not sure whether this new SQL is still new enough. SQL become, it's okay language, right? People struggle a little bit whether it should be like Python or R, maybe R or Scala, some other language. Maybe today people are talking about maybe just SQL plus Python is good enough for most of the cases.
With main consistency is the center heart of Volt. You can create replicas, you can replicate to other data centers. We support multiple data centers, active replication, but consistency is still at the core.
Okay. And do you mind sharing like what other players in this space so that me or the audience can know about?
That's a very good question, because it keeps changing and it's never a clear space, right? It depends on what the customer thinks. So some customer would still want to compare Volt with the Oracle.
Okay.
Some customers then say, well, Oracle has times 10, it's their in-memory product, can you compare against that? And some customers, they might have heard of NoSQL, or they might have had some experience with NoSQL like Redis or Mongo. And they say, hey, can I use Volt instead of this because my transactions are getting more complex. So and then the newer evolution of the cloud databases like Cockroach or Yugabyte, they're mostly NoSQL. They're still like key value stores. But we get compared with those products as well. But I feel the competition like is in the customer's mind. But from a solutions architect perspective, we want to be able to understand the customer's problem clearly and make sure our product makes the right trade-offs, right? The trade-offs that make sense for the customer. Not everyone needs transactions. Not all streaming use cases need transactions, of course. You can attest to that from a Timeplus perspective. And we want to make sure, right? We want to make sure we understand the use case and see, if here you're making the right trade-offs. If you don't have to have all of your data in memory, or it gets prohibitively expensive, then Volt is not the right technology for you. So we want to be upfront with our design trade-offs, our strengths, and where a better product might be suitable. And that's how we find different competitive differences with other products.
Okay. So Volt is a distributed system, right? And not everything is in memory. I guess there's something on disk or on object storage.
Everything is in memory, but it is durable. So your transactions and the state is durable to disk. Mm-hmm. And if you are using our Kafka API, we implemented the Kafka API as well, because we provide persistence to streams that can implement in Volt. So If you're using that, then there is durability provided to the streams as well, so that you don't miss any events, you don't miss any records. So we can provide exactly once or at least once semantics.
Okay. So regarding memory, because there are two product name or logo come to my mind immediately. A is the previous called MemSQL, you may know, and now they call Single Store.
Yes.
And the other one is Hazelcast, right? I guess
Yes.
they all heavily invest on how to run large scale, even distributed workload using memory as the best way to like accelerate things. So how you compare this technology?
Yeah, so I think MemSQL is we used to run into them quite often earlier when they were called MemSQL. Like when I initially joined Volt, we used to run against those guys. We went against them in some POCs as well. I think their strength is in bringing together both analytical and transactional together into one system. They have row store in memory and columnar store, and I think this is based on outdated knowledge. So I haven't checked their product offering recently, but their main strength is in being able to combine transactional and analytical workload together. Volt is only transactional. That's our focus, so that we can give you a latency, right? That you can get latency that is under 10 milliseconds. If your use case requires that, there's many other systems in your online pipeline. If your application is latency sensitive, like you need to make an offer to the user right away, it's a latency budget of 100 milliseconds, then you can only give 10 milliseconds to the data processing. There we find use cases, and like in edge use cases where we're seeing those evolve. They're not in production and wide applicability yet. We don't have cars communicating with each other yet. We don't have swarms of robots that are automatically, in an automated fashion, just running an entire data warehouse yet. Not a data warehouse. I mean, an actual physical warehouse. So when we speak with customers in that area, this is what is required, right? Being able to ingest lots of events at scale, and being able to transact and be able to take an action like within under 10 milliseconds. The long tail latency, I think, is that we discuss about, and that's what we optimized on. It's just in memory, transaction, ingest, use the context to process the event, and quickly push a decision out.
Wow, nice.
So I think Hazelcast is in-memory data grid. It's easier to embed into your application. It's a much more easier way of, I think, development. Mm-hmm. So it's embedded within your application. You can also have it externally. I think it's a different way of building applications, and that I think there's certainly a lot of value to that. But again, when we compare, our strength remains in low latency and high throughput performance. That it's hard to beat given understand the design choices that are made.
Yeah. I mean, nothing coming from free, right? You have to make choices to make it very clear what's your pain points, what's your goal, and what kind of other things you can put as a lower priority. And you also mentioned this low latency, like below 10 milliseconds. I'm just curious, that is, do you offer cloud service or mainly on-prem?
No, yeah, it's we sell the software that our customers then deploy.
Yeah, because this totally makes sense, because I mean, I'm not a big fan of talking about our company or project in this podcast. It's meant to be a very casual way to have discussion on people in this space. Yeah. But anyway, I mean, we have the similar discussion all the time, and because we also can achieve super low latency, high performance stuff, and cloud is okay. But if you're really looking for like sub-second or even like single-digit millisecond, I mean, send to the cloud and go back, even on the API layer, cross region can be really challenging. So a lot of folks, if they're really looking for single-digit millisecond, they will deploy naturally in their same data center side by side with their, say, Kafka or their sources.
Yeah, that's why most of our biggest share of our customers is in the telco industry, and they all deploy, on premise. So that's the strength, right? Mm-hmm. But we have more customers who deploy Volt on the cloud. Dream11, it's a fantasy cricket app in India. It's given the scale of the Indian population and how cricket is a religion. It's not just a sport in India. The scale that the Dream11 app handles is very high. So they have 200 million users on their platform. And on the day of the match, for one match, you would see 10 million users playing fantasy cricket. And most of that activity happens in like 30 minutes. So it's just a 30-minute window where most of the activity happens. So 10 million users gathered into a 30-minute window, and everybody trying to create their teams and join a contest and win the big prize. So they are all deployed on AWS, and they also need low latency because it's at scale, right? If you're not able to do it at low latency, it kind of becomes a problem in itself. And the customer experience, they really value how good their user experience is. So yeah, they're on AWS and they deploy across multiple AZs. And yeah, they also require low level latencies.
I know that is people may watch the game on their mobile and send some emoji or like chat with their friend. I mean, that's a really big thing, right? To feel that they are part of the game, to interact with their friend, with strangers. So if we can really deliver super low latency and they feel it's part of it, you don't want to say, I mean, the game already won and you are be late, like 2 minutes late to celebrate things. Yeah, totally makes sense.
Yeah, I mean, their fantasy app is essentially you build your own team and you join a contest, right? And you want to do that before the contest fills up. Yeah. And it's absolutely exactly one's processing is absolutely paramount there. That you cannot have two teams join, and you'll have to pay out more than what you have to.
So the topic about the interface, is CQ remain the main interface for Vault?
Yes.
Or do you have to add extra syntax to make this fit better for your kind of low latency or time sensitive analysis?
So the execution engine at the heart of Vault, it runs SQL. So SQL is the main language, but the thing is with Vault, one of the ways we get low latency is the data and the processing are both co-located, right? It's not a compute and storage separation. It's all in memory. So the data and processing are co-located. We're not trying to fetch data from, there's no shared memory. And there are individual partitions, each running in a single threaded fashion. So how you can build complex logic on Vault is by writing a Java stored procedure, instead of which you can use SQL to actually get state, like insert, update, delete, whatever you would like to do on the actual tables or views or indexes, use the indexes. But the logic, you can write more, complex logic imperatively by using Java. So it's kind of trying to get the best of the both worlds, right? If you are familiar with SQL, you can just write your SQL statements. But if you need to do more complex, you don't have to bear the ills of the procedural languages like T-SQL or PL-SQL. Write easily in Java, and that's automatically run and taken care of, and you don't have to worry about it.
So it's more than Java, say, user-defined function UDF, right? So it can be like background job to keep aggregating data with certain state, even do some CEP like complex event processing and send data to some other tables. So the table is already with the right event or the result, right? So it can be, assume you support UDF and also the procedure or background job in the same time.
Correct. Yeah, we have tasks, what we call, they run in the background. The UDFs are an easy way for you to implement a function that you can embed inside your SQL statement. But the stored procedure is the master, right? Inside the stored procedure, all of this can come together.
Okay, nice. And how the data come in? Is Kafka one of the key data sources, or you expect people calling API, SDK to send data directly to your database?
Kafka is pretty popular, but you look at the low latency use cases, right? They don't want to create this additional hop.
Exactly, yeah.
Throw it on Kafka and then fetch it from Kafka. So our low latency use cases, they use our SDK like a Java, C++, Golang. We don't have Rust yet, but we have Python. So you can use this SDK and write, push your events or do request response as well, right? You can use that pattern as well. But we've also added the Kafka API support. So you can point your Kafka publisher at Vault and say, here's a Kafka broker and just publish your events to it. So that makes it a little bit easier for adoption.
Yeah. I mean, especially you mentioned something like telecom or IoT. Maybe they may prefer like MQTT or some other NATs protocol can be a buffer layer if they're okay with that. But if we're really aiming for lowest possible latency, maybe directly using SDK will be best way to achieve that, right?
Yeah, exactly. And our client will do a lot of optimizations, making sure that it can, if you want them to be batched, it can batch by partition and just ship those batches off. So if you need to load like a huge CSV file, right, the client can optimize for that. So we do that with the Kafka, and we have importer as well, which is essentially a Kafka connect, but it runs on the Vault cluster. So it creates a Kafka consumer, goes out and pulls the records of the Kafka topics. So there's different ways: push using the SDKs, push using the Kafka publisher, but also pull using our importer. And on the other side, there is push using the exporter and pull using the Kafka API.
Okay. So we talk about real time and the low latency a lot. And also I drink a lot of coffee, and this is streaming caffeine. So about streaming, do you guys support something workload similar to like stateful stream processing, more than just like a bounded query? So for example, how you send out those continuous result back to the client?
Yeah. So as I've been explaining, our foundation is from, as you said, like bounded dataset queries and SQL. So if you want to run continuous queries, you can define like a materialized view that can, you can mention that it can be tied to an export target. So it continuously keeps on sending data out. Or you can write like a TTL on a table, data out. Or the most expressive option is to use a stored procedure. And in the stored procedure, you say, here's a credit card swipe event. It's coming in, right? I'm ingesting all the credit card swipe events. I'm checking against the window of what happened in the last 1 hour based on a pivot, which is, let's say, the credit card number. And if it's a fraud, let me write to this stream table. We have everything in the relational model, right? So stream is also a table. So you just insert. There's only inserts. You can delete, you cannot select, you cannot update. And that stream is essentially your interface to an external system, whether that is a JDBC database or whether that's Kafka. So you can do per event processing, right? Every event comes in, you decide, hey, this looks like fraud, so I'm going to push this down the stream. Or if it's not, then I'm just going to add it to the table, which will continue to serve as my context.
Yeah, I would say per event processing can achieve a lowest possible latency, right? Because you don't really have to take care of the context. But say if you have to check some of the previous event, say if the user already do certain actions 3 times in this second, and we should not allow them to do the fourth time started that. So how about today handle such like stateful kind of processing?
Yeah, so it's a relational database at its core, right? So going back to the same example, I have a transactions table, let's say, and the table is in memory and it is durable. So in the case of a crash or system failure, you can recover the state from the disk. And in your stored procedure, you look at the attributes of this event and you can insert those into the transaction table. So that serves as your context. So before inserting, maybe I'll query the transaction table and say, select where credit card number equals this, count of the transactions in the last 1 hour. Maybe that can be a select, or that can be, I can already define a materialized view on top of the table. So the count is continuously being calculated. The window is already created. So instead of querying the table, I'll query the window. So the window is, querying the window is simply select, the count in the last 1 hour. It's a column, let's say, right? That is being continuously calculated, where credit card number equals this. That will give me the count. Count is 4, not a fraud. Insert into the transactions table. Count is 10, it is a fraud. Don't insert into the transaction table. You can return back a response saying this is fraud, or you can write out to a stream if it is more event-driven architecture.
Okay. And I noticed, is that this month or like the previous month, you guys have a linking online event talking about streaming database? This is can be easy topic. So what's your current take on this idea, and how relevant it is to Vault, or even like how you think of Timeplus or Proton? Can you share about that?
Yeah, so I think it describes it's a very good like a category to describe the different products in this space. Streaming database, right? I think we're going back to the foundation of having SQL, having the ability to query the state. I think that's important. So we're going back to that, but in a streaming world where the data is continuously flowing. So I think I love that that category. From a Vault point of view, if you had told me like 6 years ago or 7 years ago, hey, there's this category that's going to come called streaming databases, then I would say, yeah, perfect. Vault is it. But I see the nuance here, right? Well, it's not so nuanced. The big difference is most of the products here are catering to the analytics, if I'm not wrong, analytics and OLAP kind of a use cases. So as Vault, I believe, it's a transactional streaming database is a term that applies to us and clearly explains, what we do. So wanted to like talk to the community, start the conversation with the community, and also put our idea forward that, perhaps this would be a transaction streaming database might be a good way to describe maybe a thin slice of use cases in the streaming world. We want to make sure we help the customers out, right? We want not like fight against technology, but help understand the customer better, help the customer understand better that, hey, in this category, these are the challenges, and we are addressing those challenges in this category in this way. So if that makes sense for you, maybe we should talk. So transactional streaming database, we believe is kind of addresses that niche in the streaming world, and we want to position ourselves, in that category and make it easier, right? Eliminate the inefficiencies in the system. That's our job.
Yeah. Transactional streaming database, cool. Yeah. So one more term to learn, to invest and to debate, because I guess like people all get idea about transactional database, right? So ACID, all those other stuff, but yeah. I guess even it's arguable whether MySQL or Postgres provide good enough transaction, right? So, but they really focusing on so-called web scale, right? So you can have a lot of servers, but if you are looking for like single-digit millisecond transaction or like low latency, you might hit certain issues. And I guess the reason why you put together as a transactional streaming database is to highlight it's transactional, but it's just as fast as streaming. It's continuous streaming, continuous processing, and it's database for sure. And for us, for a while, we even put this streaming OLAP database as a test on some of our linking posts or some blog. My impression that is developer are usually very straightforward, and they're willing to embrace new things, but they can also say, oh, I don't like this, I hate this, I've got confused, I don't. But so there's a lot of new words coming every day, and some words we don't really use so often as before. So this streaming database is a new category. Even if you notice that people argue a lot regarding whether there's a category called vector database, right? Some people say, hey, this is really a big market because of the rise of the AI, but some people say, come on, it should be just part of the extension or add-on for Postgres, right? For example, it doesn't deserve a new category. People never really have a good understanding about, hey, this is a good big category or not. Maybe this will apply to streaming database similar way.
There's ambiguity, right? There's confusion. So, there's different solutions. Some might work and some might not. Some categorizations might stick and some might not.
But yeah, and also all those categories is really an objection to describe the sophisticated product to someone new in a simplified model, and of course it will lose certain details, create some confusions. And some engineers or developers can be very passionate, open-minded to embrace new things. Some just really wanted to find a better version for whatever workload they are using today. So maybe a little bit hesitant to embrace those new tools. That's also some of the discussion we have in Timeplus team. That is, streaming database certainly is a fancy term, and we even can be one of the most ready players because our engine is powered by ClearHouse. So it's a very mature OLAP database, and we have extra streaming capabilities. But whether we really always using this streaming database or streaming OLAP as a way to talk to customers, because always case by case, but in many scenarios, the person don't really want to locate a category and find what is the best one and try it. It's more like I have a problem to solve. I have a lot of problems to solve, or my problem is not to solve good enough in the current tool. Can I improve that? Can I make this easier? Can I have a cheaper option? Things like that. So, like for example, in many cases, some of our clients they don't really use the term like streaming a lot, right? They feel like this is more like implementation details. What do they want? That is, they have a lot of data changing all the time in their kind of a TV system. How to have some analysis to understand what's going on, like those real-time metrics, right? Or even send some real-time alerts when something goes wrong. So that's what they want. They want a low latency. They might have some context or they have some state, but their first question is not, I want a streaming database. They want to solve that problem. And streaming database may help or may not, together with other stuff like CDC or those components or building blocks. But in the end, it's really a very practical problem to solve. Yeah, there's a lot of way to sell to developers. Maybe sell to developers is one of the most challenging things because developers are so smart, they can build it by themselves, but they can be very picky. They don't really enjoy those buzzwords, but it's also very fun to work on the tech domain.
Yeah, I mean, I see NewSQL was a buzzword because it wasn't really describing what is happening. It was just saying, hey.
There's also some term like new BI or agile BI. It's hard to digest what is the new. And if you talk about this new like 10 years ago, that's still a new thing today.
Yeah. But I think it's good to be descriptive, which is what streaming database is. I think it's a descriptive way of talking about your product. And yeah, we have to get to that momentum, right? It would be great if we get to that momentum where it's widely accepted. But the customers, they fall over, very wide range. As you're saying, they don't even talk about streaming, and streaming database probably doesn't make much sense to them. So yeah, it's interesting that you have to educate. I don't know if it's like educate, but like bring them under the umbrella of streaming, the different use cases.
Yeah. Certainly the customer need or the current kind of a maturity level or how they set up the system is quite different, a wide spectrum. Some folks still really worry about how to like turn some of the hourly batch job to be like minute based or second based.
Right.
Yeah, I mean, some of them are really talking about can I have a super like low latency CDC to see what is happening like 2 seconds ago. So people have very different requirements for sure, and there's a lot of technology to play the role. What's the next chapter? What is coming like this year or the year following that is in terms of streaming processing or the OLTP or AP? Is that going to be merged or it will be do one thing, do it well style? What's your thought on those things?
I think there is we have to first find a dimension. There are so many dimensions on which we can do the separation. So one dimension I would separate on from the OLTP point of view, if we take it, like the cloud databases, they're focused on OLTP. Better for storing, transacting and storing lots of data, right? And on the cloud, provide the compute storage separation. And there, I think the emphasis is on providing high availability, being like CockroachDB advertises itself as it's a database that would never die. Yugabyte and Span are also fall in the same category, right? So that's a capability that some customers are looking for, right? That you can never, you want to limit the blast radius whenever something happens. Maybe you just lose the service to 20 of your customers, but the rest 80% should be able to transact, and that's what your system, your business depends upon. I think on the streaming side, since we fall in that intersection, looking at from the streaming side, state is becoming more and more important, and people are discovering the challenges in whether it was KSQL earlier, Kafka Streams, KSQL DB, and now even Confluent has put their money into Flink. So, how do we provide better state access to our streaming, stream processing? The I think time flow and differential data flow, those that model is very interesting, and I think it's great that you are able to implement that. But being able to implement that along with state, I think, is a tough problem that uh, not all products were built to solve. So we are seeing growth in that area as well. It's not just stream processing, but stream processing with guarantees, or if it is OLTP at scale, while providing these guarantees of being able to survive the loss of different kinds of failures. So I think some will merge, right? Some products will merge, and some products, in some ways, they are going to diverge. So what we see, I mean, I can only tell what I see from our customers. Uh, they continue to want the guarantees. 5G is, we see 5G on our phone, but it has not brought any transformative applications, not like 3G did, right? 5G is still doesn't mean much, except it's faster, except at least to the end consumer. So the disruptive use cases that 5G was supposed to bring, with the low latency, with the ability to handle lots of devices, right? Those were the main benefits that 5G was going to bring. Use cases haven't been able to, there's no really popular use case out there. So when those happen, I think the need for merging this OLTP and streaming will really come out, that you have to optimize your network, right? If you are providing a private 5G network just on in your baseball stadium, right? You want everybody to be able to talk about the game, share pictures, and say what great time you are having at your location. But if you're just relying on the regular cell service, your videos and photos are not going to get uploaded. So you have to be able to optimize your network performance based on the demand, which can be very highly variable. So in those scenarios, being able to take really quick decisions on lots of different kinds of streams of events, I think, is going to be critical. And that's what we see in the future for Volt. Those are the kind of use cases we're really working with our customers. Most of our customers are, we have a few customers who are end users of Volt themselves, but most of them are solution builders. So they are working for their customers. They're trying to build these futuristic solutions and saying, here's what is possible that we can provide you. We're just waiting for that market to mature and say, yeah, create that need in a consumer market. That need exists in a private and smaller markets. Looking for that to take off when 5G network becomes widely available, and lots of other factors come into effect.
Yeah, cool. And I'm glad you mentioned this concrete scenario or sector about 5G, right? So I do see some use cases like people using 5G to remotely control those trucks. They're mining stuff. They all those area with a lot of pollution. It's not safe for a human being to drive, but the road is not like highway. You need a lot of skill. So people, those are experienced driver. They just like in a driving seat in more like simulator thing in their office, but they are driving the car, the truck in very low latency because of the 5G network, right? So it's not like self-driving because it's more challenging than regular road condition, but need still people involved. But because of the 5G, the low latency is possible. And even the worst thing happen, the truck will be destroyed, but the driver is safe because they are in office. And
Right.
it's very hot out there. They have all the air conditioning in the room. So yeah, 5G really bring those things to like from the kind of sci-fi kind of thing to a real thing. And with all those sensors, we really can come to more use cases about what is the transactional data, what is things to be in the real time. Right, so I do looking forward to that kind of next wave of the adoption of 5G and more use cases like that.
Yeah, I think that's automated decisions at scale where you have to be correct, because the risk if you're not correct is something actually physically wrong happening, right? Bumping into something else, having an accident. Yeah, so those are the critical use cases.
Yeah, similar thing for the manufacturing, for any like oil mining, all those things that is we can leverage 5G to connect things together and have more data points and make better decisions, or have more real-time alerts or real-time dashboard to help us to make decisions. That would be fantastic.
Yeah, I think the smart city initiatives that some cities are taking up, right, those will provide that scale, or those will require the problem to be solved at scale. Like, you have, instead of manually figuring out your traffic cameras or having a simple algorithms to, or heuristics to decide when to turn red and when to turn green. I think that should all be automated at a high level, so that you have a strategy, you are able to control the traffic flow and optimize your city's traffic. Which
we apply stuff like digital twin or other
right
thing that is you can simulate your decision in that digital twin and see how things going. Is that going good or bad? Then apply back to the physical world
right.
in the kind of a real-time fashion. That would be awesome.
I mean, I live in the greater Boston area, so traffic here is a nightmare. I think we were rated as one of the worst cities for traffic.
Yeah, when there's more like self-driven cars, I mean, the theory that is people can coordinate better regarding like the traffic light, so everyone accelerate in the same time. So maybe the traffic jam will be better, but I don't know. Maybe people just stay home using Apple Vision Pro to play a game or work all the time. Maybe less car on the streets. I don't know what there will be. Yeah, it's such an interesting future. I'm looking forward to meet you somewhere in some conference or have one more online event together.
Yeah, I appreciate the opportunity for Joe to be able to do that as well.
Okay, cool. And that's the first episode of the Streaming Caffeine this year.